Welcome back to the workshop once again for one last example discussing alternating series. Now this is just kind of a supplementary example, just something interesting to consider. But it really highlights the importance of the concept of absolutely and conditionally convergent series, or at least demonstrate something that happens for conditionally convergent series. So we're going to consider a rearrangement of the terms of this series, which is a conditionally convergent series. Now we haven't discussed that in any videos that I have created, but that is something that after watching recent videos, you should be able to determine for yourselves. So I'm telling you this is a conditionally convergent series. And I just wrote out what the first 8 terms are in the series. And I'm telling you that the sum of the series is exactly the natural log of 2. I would not expect you to know that right now, unless you're considering this video as a review and you already have a good knowledge of calculus content. So this can be observed after a discussion on Taylor series approximations for functions, or Taylor series representations. Of course, that's includes a conversation about Maclaurin series. So whichever the details are there, I'll let you investigate those. But that's something that in a Calculus 2 course you should certainly see. So in the future, you'll see why this is exactly equal to the natural log of 2. But right now, we want to simply say it is. So let's take a look at what happens. All right. What I'd like to do is I'd like to rearrange my terms. And because this is a series that is conditionally convergent, we're going to have something essentially bad happen. So this is equal to the natural log of 2. Now, if I just consider my series here, my terms, I can rearrange them in the following way. So what I'd like to do is I'd like to take the 1 minus 1/2 and group those together. Then what I'd like to do is I'd like to take, let's see here, I'd like to subtract 1/4. So I'm using this term, this term, this term. Now what I'm going to do is I'm going to add 1/3, picking up that term, and also picking up this term, minus 1/6. And then I'm going to subtract 1, let's see here, 1/8. That's what I would like, 1/8. There we go. And then I'm going to add, let's see, the next thing that I would do would be 1/5 minus 1/10. And then I can subtract 1, let's see, I don't want 6, 10th, 12th is what I would like there. And I would continue adding on. So this is a rearrangement of the terms. You'll notice that every term would get used by rearranging them in this way. 1 minus 1/2 is simply 1/2, so minus 1/4. 1/3 minus 1/6 is simply 1/6, minus 1/8. Let's see here, 1/5 minus 1/10 is exactly 1/10, so plus 1/10, minus 1/12, plus so on. From here, I can pull a common factor of 1/2 out of all of these. So this is 1/2 of 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5 minus 1/6. It would continue on plus 1/8. I'm sorry, plus 1/7 minus 1/8 plus, and so on. Now that should look pretty familiar. When we do that, that gives us our original series. So this is equal to 1/2 of the natural log of 2. What? No, it can't be. Is it really? We just said that this thing is equal to the natural log of 2. And we used that fact right here. But when we rearranged these terms, we ended up with an additional factor of 1/2 that we pulled out front to say that this is 1/2 of natural log 2. So 1/2 of natural log 2 is equal to natural log of 2. The natural log of 2 would have to be 0, and we know that's not the case. So what exactly is going on here? Well, because it's a conditionally convergent series, when it is in this form, when it takes on this particular representation, we get exactly that it is the natural log of 2. But it is possible to rearrange terms to end up with a different value. If you were to consider an absolutely convergent series, you would not have this issue. You don't have that capability. If you're interested more in that, I would encourage you to pick up a Calculus 2 textbook and to refer to the section on alternating series. There should be some footnotes in there and some nice historical citations to give you additional readings to consider if you're interested. Thank you for your time and your attention. I hope you guys enjoyed this video, and I will see you back in the workshop again soon.